page 43. Okay, and it's 6 x plus 2 equals 7. Okay, so what we're going to do is I'm going to solve this the same way you did. And we're going to technically do all the same steps you did, but we're going to take 2 of the steps and combine them into one step. So the first thing we're going to do is the first thing you did, is we're going to subtract each side by 2. This leaves us with 6/5 x. This is just 0, so these cancel. And 7 minus 2 is 5. So what you did is you multiplied each side by 5 to cancel here. And you did 5 by 5 is 25. And then you divided each side by 6. So what we're going to do is we're going to put that multiplication and division in the same step. So what I'm going to do is I'm going to multiply this by 5/6. And so notice what that does. So notice that this still cancels, right? This is in the numerator, this is in the denominator. This still cancels. And then look here. I'm still doing 6. This is in the numerator, this is in the denominator. This is still 6 divided by 6. So basically the same thing. This is like 5 divided by 5, which is 1. This is 6 divided by 6, which equals 1. So in the end, I still have 1x. So these cancel too. So then I just have x here. And so notice that I'm doing the 5 times 5. I'm still multiplying by 5 on this side. And then I'm still dividing by 6 on this side. So I still get the same answer. So let's look at it again, what I did. So I'm going to rewrite it one more time. Plus 2 equals 7. So I'm going to subtract the 2 like I did last time and get back to this step. So all I did is I multiplied each side by the reciprocal of this. And remember the word reciprocal? Of a fraction. What that means is swap the numerator
and denominator. And it'll still be the same regardless.
It's not the same, so it's not the same number. That's important to realize. So the reciprocal of 3/4 is 4/3. So these aren't the same number. It's just this word lets us refer to this idea where we swap the numerator and the denominator. So what we do is if we multiply, so if we have a fraction if we have our variable being multiplied by a fraction here, the way we can get rid of this whole fraction in one go is we multiply it by the reciprocal. And whatever we do to one side, we want to do to the other side. And so when we multiply the reciprocal, notice that we can just do 2 cancellations in one step. This 6 is in the numerator, this 6 is in the denominator, so we can cancel. This 5 is in the numerator, this 5 is in the denominator. They're being canceled.
Right.
So, and also, since this is all multiplication and division, we can do this. If this was a plus for some reason, like say we had a problem, this was a plus, we could not do this. That's a different problem.
Why is that?
Because when you multiply fractions, you multiply the numerator, 30, and you multiply the denominator. So the numerator and the denominator end up being the same, so you get that 1. But when you add fractions, this is different. You don't just add the tops and you add the bottoms. We actually have to get the same denominator to allow us to add. So in this case, what we'd have to do is we have to do to do this problem, we actually have to make the denominator the same number. So I want to make them both 30. So 6 times 5 is 30, and 5 times 6 is 30. But to multiply the bottom by 6, I have to multiply the top by 6, so this is 36. To multiply the bottom by 5, I have to multiply the top by 5, this is 35. And this is 35 plus 36, which is 71 over 30. So I don't find it really needed to show you how to add these together. I mean, we can talk about that more later if you want. But realize this only works for multiplication, because when we multiply 2 fractions, we multiply the numerators and we multiply the denominators.
Okay.
So because this is a fraction being multiplied, we can multiply this fraction by its reciprocal, and that's when we can do the 2 cancelings.
Okay.
And so, since we multiplied by 5, 6 on this side, we multiply by 5, 6 on this side, so we get that 5 times 5, which is 25 over 6. And then we're done.
Okay.
So yeah, let's try to do some more of these problems.
Okay.